So let's just take a look at what we did before. So we came up with a table of both cases, right? So there's two people or two companies or something. We came up with a table, and on the table we just counted out, and we found when did we find out that they're both the same. So we stopped our table right here when we found out, oh, they both cost the same after 3 cars sold. They both make the same amount of money. That's what it was. Right? Now you need to know that so that when you're graphing, right, you finally graph it, you know where it's supposed to intersect. Okay? Otherwise, we don't know how high we should be counting on the y-axis if we don't know where they intersect. So that's important. The second thing is that later on they asked us, well, how much after 5 cars? So we also want to make sure that our x-axis went up to 5 here so I can see what the answers are there as well. So there's a few things to look after and then help us decide, well, what number should we be trying to count up to on our y-axis? All this is trying to figure out what to count up to. I don't want you guys just always only doing like 0, 1, 2, and 3 and stopping. The reason we stopped here was because that's where they're the same. So as we keep on doing these, you're going to stop at different places depending on where you find them intersecting. It might be after 3, it might be after 10. If it's after 10, we'll have to make tables that go up to 10 so we can see that. So you should be able to see the same information on your tables as on your graphs. Okay, all the same stuff. Okay, and we'll know ahead of time that if we see them the same on the tables, we know that that's where the two graphs should intersect. So it's not like a surprise when you're graphing it what this should look like. You should expect, oh, it's going to intersect here because on the tables that's where it's the same. Okay, so let's go ahead and do a very similar process, but new situations today. Okay, so start off, we got 2. We're still sticking with 2, but we could do 3, 4, compare 5 companies at once and really have a lot of information in one table. But we're just sticking with 2 for now. And go ahead and let's make some tables. And the neater, the better. Right. That way we can understand what's on our graphs. So we'll make 2 tables. I'm going to be color coding everything the best I can, so you can see clearly what is what. If you guys were making these like for the presentation, you'd probably be making it on a computer, you know, where you can easily change the colors of lines and label them pretty carefully. So we have 2 companies, right? So let's label them first off. Let's call this one on the left the leap jump, and the one on the right, I'll just call it the point with an E. Leave out the perfection part. And it tells us still what do the X stands for right here. Number of classes. Now later on it's not going to tell you what's X and what Y, so try to pay attention to how would you do that if they didn't tell you. Could you figure it out from the information in the question that X's are classes and the Y's are, well, anytime you see a $sign, the Y is going to be the cost. But there's different words for costs. It could be revenue. It could be many things. So, and yes, these do count. Having the title of your table, just like having a title of your graph, labeling the lines, all that stuff actually will count for actual points on all your quizzes and tests for these. Because we want to be able to look at each table and know exactly what it is that we're looking at. So let's try counting up to 1, 2, and 3. Now we went up to 3 last time. I want to show you what happens when we go up to 3. So let's just start going up to 3. We'll probably go up more. The leap jump starts at $20, right? It goes up $12 per class, so I'm going to increase $12 per class. And the point perfection starts at 60, right? A little more expensive to start off. And it only goes up $4 per class, so much less. So let's just fill it out up to 3 by adding the same amount each time. So 20 plus 12, and 32 plus 12, and 44 plus 12. Okay, let's go over to the point perfection. 60 plus 4. And 64 plus 4. And 68 plus 4. 72. And here's where we stopped before, but you can see they're not the same. So we got to keep going. We're not going to just stop at 3 automatically because it's a magic number. We have, the purpose of this is to keep going till we can see, well, where are they the same? So let's do 4, 5, 6, and 7. And I'm just guessing on this. I don't know if one of these are going to be it, so I'm kind of leaving room just in case. And this will happen on every problem. Every problem will be different. It's going to intersect in a different place, so you can't count on it always to be, right at the beginning. So let's just keep counting by 12s on the left side here. So 56 plus 12 is 68. 50 plus 12 is 80. 80 plus 12, 92. And 92 plus 12, 104. Okay. And then continue counting by 4s on the other side, going up by 4. So 72 plus 4, 76 plus 4, and 80 plus 4, and then one more. So have we found where they're the same? Yeah. 5 classes, both cost $80. So we know when we graph it at 5, 80, that's where they should intersect. One's going to be more cheaper at one point, and then once you get to 5, that one that was cheaper is now going to be more expensive. That's that break-even point. All right, so step 1 is figuring out the tables, but also figuring out how far do you need to go on the tables to get all your information. And you can also cheat a little bit and go over here and go to the back and see the questions, because like before they asked us here, like, where was it? Oh yeah, just randomly asked us right here, 5 cars sold. So we had to make sure we went up to 5 on our graph, which was after they intersected. So we can look at it here and see they ask us any questions. Oh yeah, they ask us about what happens at 6 classes. So we want to make sure on our graph and our table we at least go up to 6, and it looks like, yeah, on both of these we went up to 6 classes. So we have all the information we're going to need for all our questions, and we just have to continue on. All right, so let's go ahead and graph these. So we need to know, we really need to go up to like 6 or 7 on the x-axis. So let's go up to 7. Now, I could do this, go 1, 2, 3, 4, 5, 6, and 7, but then I only use this tiny little bit of the graph. The graph will only be here if I count by 1s. So just to use more of the graph, right? Just to make sure I use more of the graph, let's use every other. Let's go 1, 2, 3, 4, 5, 6, 7, and why not go to 8? Of course, this is 0 we're starting at. So we want to use as much of the graph as possible. And this is really the part where you have to do the most thinking on these problems, is figuring out, well, what should I count by? I need to fit at least this amount of dance classes, but I want to use as much of the graph as possible, so what should I count by? So we can say that's going to be the classes. Always label your axes. So if somebody didn't read the question, they could still look at your graph and know exactly what your graph is, what it's graph of. Now for the y-axis, what's the highest we need to go on the y-axis? What's the biggest number? Here's where they intersect, but we need to go past that, right? Because it asks us questions of what happens at 6 classes and so on. So 104 or 100-ish, so kind of round it around 100. So we need to count up to 100 on here. Start at 0 and get up to 100. So what do we need to count by so that it fits? All right, so if you count by 10s, let's try that. 10, 20, 30, 40, 50, 60, 70, 80, 90. So we really could stop here, and we wouldn't use hardly any of this graph. So we probably want to count by something a little bit less, just so we can use all the graph. So it's a bigger graph and it makes more sense. All right, now, so let's try counting by fives. A little erasing. So that would be every other square would be 10. So if we go 10, 20, 30, 40, 50, 60, 70, 80, 90, well, there's a problem right there. It doesn't make it up to 100. So 10s is kind of too big of a number. 5s is too small of a number. So we need to pick something between 5 and 10 to count by.
2.
So I said something between 5 and 10, and people said 4 and 2. Come on.
Come on, Jack.
Let's try it again. 6s or 8s or something like that. 6s? Okay, so let's try 6. 24, 30, 36, 42, 48, 54, 60, 6, 72, 78, 84, 90, 96, 104, and 110. So that fits everything. So we can use 6s. And if you use like 8s, that would probably work as well. So not necessarily a right or a wrong here. Is that right? Plus 6? Oh, thank you. Oh, 2. 108. Good eye. And what is this? What do these numbers mean again? 108 what? Dollars. So we're talking about cost. So label the axis so we can easily see we're graphing the number of classes versus how much it costs. All right. So I believe that's probably the hardest part of the whole thing is now that we've done a few, we know how to work the numbers. It's just coming up with the right scale so it fits all the information in the biggest possible area as possible. So let's go ahead and just plot these. Shrink this down a little bit so I can see it. So my leap jump starts at 20. So let's just go ahead and graph 0, 20. Right about here. Then we have one class is $32. So right about there. 2 classes is $44. So we're going to have to estimate a little bit because I go from 42 to 48, so 44 is in the middle there. Right? And after a few, you already know this is a linear equation, so it's going to be a nice straight line. So you could just draw a line, and that'll help you plot all the points. So 3 should be right about here. Right? It's a little bit above 54, and if you go to your table, yeah, 3 is $56, so that will work for you as well. Okay. And of course, label this so when we're finished, we can actually see, oh, this one's cheaper. Or this one's more expensive. We just have 2 lines on there. We don't know which is which. Then we can't really tell if it's cheaper or not. So let's call this one the leap jump. Label it so we know that it's cheaper. And then do the same thing. I'm going to switch to red and graph the other one. See how it goes. So this one starts at $60. Then goes to 64. And we know they're going to intersect at 580, so I can expect somewhere around 5 right here. That's where they're going to intersect, at 580. Okay, and we can just fill in the rest of these. And we'll label this one point. Perfection. So we can tell which is which. Now, which one's the better deal? That's always the question, right? That's the last question. So which one's the better deal? You tell me. What do you think? And remember, this is not a... When I ask what's the better deal, that doesn't mean pick one, right? Because neither is a better deal all the time. So remember, that's a trick question. So when it says which one's the better deal, you got to say, well, for 0 to 5 classes, this one is a better deal. But when you go over 5 classes, because right here, all of a sudden it switches which one's a better deal. So when you get to the back on number 8, the very last question here, what ballet is the better deal? You have to specify, okay, for 0 to 5 classes, okay, dot, 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 which one's a better deal, and then follow it up with for 5 or more classes, okay, dot, 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 the other one, the other company is a better deal. So a better deal doesn't mean, oh, this one, unless, of course, one of the graphs was entirely underneath the other graph the whole time, then we know that one's always a better deal. By the way, which one's a better deal? Is it the one above or the one below? When we say better deal, which one should we be looking at? Below, right? Better deal means cheaper. So on the last problem, we're looking at above because better meant more money, making money, right? So if you're making the money, you're talking about money that you make, better means looking above and which one's more money. But if we're talking about paying for something, better deal means which one's less expensive. Yeah, you get the same thing for cheaper price. So be thinking about the question. It's not always the line that's going to be above. It depends on what kind of question you're trying to ask. Are you making the money? More is better. Are you spending the money? Less is better. Okay, so with all that information, so on here, yeah, you're really looking right here, right? That's what's cheaper, that's what's better. And then when you get to here, this is the part that's cheaper. So this is the part that you would want to look at and see, yeah, leap jump is cheaper right here for 0 through 5 classes, right? The leap jump's cheaper. As soon as you get to 5 classes, now the point line is underneath, it's cheaper. So you want to go with point after 5 classes, anything more than 5 classes. Okay, so hopefully that helps. Okay, most of it what I showed you was what I just showed you about better deal, what it means. Okay, it's the lower the better. And then how to come up with all these numbers on the left-hand side. This is one way of doing it, not the exact right way, but one way, okay, for picking the numbers. And knowing what number we need to count up to when we're doing tables. We have to keep going until we figure out where they're the same, so we know how far we need to count when we start graphing. Alright, so your goal for the rest of the period is just to finish up the rest of this one using the same thing we did before, find the slope, find the y-intercept, and then do another problem that's very similar all over from beginning to end. You'll notice on this problem, we waited to find the equation until after we actually graphed it. The last problem, right, we found all the equations, right, 500x plus 1,000, and then we graphed it. So we didn't really have to do it in a certain order. We're just doing it in a different order just so you can see the order is not important. You can do the equations first, then graph, or vice versa. It doesn't matter. Okay? All right. Go ahead and work and check with each other a little bit before you turn it in. The number one things I've been sending people away when they try to turn it in is for not having labels. Right? So if I can't see what your graph is a graph of, and I can't see the names of the lines, I don't know which is which, so I can't tell which one's cheaper. I know one's cheaper because there's one below the other, but if I can't see a name, I don't know which one's cheaper. So make sure you have all these labels for your graphs before you come up and get checked off. And that's it.